In this task, I'm going to geocode some data. My organization has a comma delimited text file with addresses for all of Baltimore's dialysis centers. I'll geocode these so I can put the dialysis center points on the map. Here I have QGIS Desktop open as I left it at the end of task 2. I've gone ahead and added the streets layer and the CSV file to my map document. You can geocode within QGIS using a plugin named mmQGIS. To install this plugin, I'll go to the Plugins menu and Manage and Install Plugins. In the search bar, I'll type in mmQGIS. I'll select the plugin and click Install Plugin. With it installed, I'll close the Plugin Manager. The mmQGIS plugin appears as a menu, and it has many useful tools. For geocoding, I'll use the tools found in the Geocode option, which includes Geocode CSV with Google OpenStreetMap or Geocode from StreetLayer. The first allows you to geocode a table of addresses using either the Google Maps API or the OpenStreetMap Nominatum web service. This tool requires an internet connection but no local street network data. The web services provide the network. The second tool uses a local street network dataset with address range attributes to geocode the address data. I'll use the Geocode from StreetLayer option. For the input CSV file, I'll browse to my lab data folder and choose the Baltimore Dialysis CSV file. Click Open. I'll identify the street name field and the street number field using the drop-downs. The street layer is street CL. The street name attribute is FE name. Then I'll populate the left from number, the left to number, the right from number, and the right to number. For the output shapefile, I'll browse to my lab data folder and name it Dialysis Centers. I'll also browse to my lab data folder and name this Dialysis Centers Not Found. The Not Found output list will save a CSV file with information on any records not matched. And once I have everything set, I'll click OK to run. The operation will take a minute or two to complete. Meanwhile, a status message in the lower left corner of QGIS Desktop will inform me of the status. When complete, I'll see the results in the lower left corner of QGIS Desktop, and the shapefile will appear in the Layers panel. In this case, 21 out of the 22 records match, which is a pretty good success rate. I'll open the Dialysis Centers Not Found CSV. It has the one record that didn't match. We won't deal with this one record for the lab. However, knowing which ones did not find matches will allow you to try and troubleshoot them later on. For now, I'll close this table. I'll remove both the Baltimore Dialysis Centers table and the Dialysis Centers Not Found table from the Layers panel, as those were intermediate steps. I'll style the dialysis centers with yellow stars. To do that, I'll double-click on the layer to open up Layer Properties, and I'll switch to the Style tab. And I'll click the Star option and change the color to yellow, and make them slightly larger, and click OK. I'll also turn off the streets so we can see them better. Next, I'll label the layers. I'll open up the Layer Properties again, and this time switch to the Labels tab. I'll check Label this layer with, and from the drop-down, I'll choose the Name field. On the Text tab, I'll change the text size to 6.25. Under Formatting, I'll enter a space as the wrap-on character. This will put a carriage return in after each space in the name, wrapping the label onto multiple lines whenever a space occurs. Under Buffer, I'll check Draw Text Buffer. This produces a halo around the label. Under Placement, I'll enter a distance of 2. With all of this set, I'll click OK and close Layout Properties. And I can see the dialysis centers labeled. Finally, I'll turn off all layers except the Neighborhood Diabetes and Dialysis Center. By bringing all of these data together, you can now begin to visually analyze the data and look for spatial trends. A picture truly is worth 1,000 words.